So today we're looking at a piece of hardware that it creates a bit of a disconnect when you first see it. Looks like a normal cable you'd find in a box, but it costs, get this, $544.
And that's the sale price.
That's the discounted price. The MSRP is closer to $700. We're talking about the Kramer CLS-AOCDP-UF-131.
It definitely makes you do a double take. But if you're in the world of professional AV installs, you know that price isn't for the rubber and plastic.
Yeah.
It's for the guarantee that the signal actually gets from point A to point B perfectly.
Right. And that's what this deep dive is all about, the sort of hidden infrastructure of these high-end setups. This Kramer cable is what's called an active optical cable, or AOC.
And that's the key. It looks thin, only about 4.8 millimeters thick, but inside, it's a completely different animal.
It's not just a passive wire.
Not at all. It's a hybrid. You've got 4 strands of 850 nanometer multi-mode fiber optics running right alongside 8 copper wires.
Okay, so that hybrid design is the secret sauce here. Because pushing a high-res signal over the distance this thing covers, what is it?
It's 40 meters, or 131 feet.
131 feet. You just can't do that with copper alone, not without serious signal loss.
Yeah.
Attenuation would just kill it.
Oh, absolutely. The signal would be mostly noise by the other end, or you'd need a cable as thick as your arm that you can't bend.
The fiber is for the heavy lifting.
Exactly. The video data is converted to light. Photons don't really care about a 40-meter run, so that's how you get a perfect 8K signal at 60 hertz with 0 dropouts.
But if it were pure fiber, you'd need to plug in power supplies at both ends, right? For the converters.
You would. And that's where the hybrid part is so smart. Those 8 little copper wires handle all of that.
So it draws power right from the source device.
Yep. Pulls less than half a watt directly from the DisplayPort connector, so you don't need those clunky wall wart power adapters.
That's incredibly efficient.
And the copper also handles the digital handshake, the ED and HDCP 2.2 copy protection.
Which is critical.
Yeah.
I think people forget that modern video connections are a two-way street. The display is constantly talking to the graphics card.
It's a constant conversation. And trying to do that handshake over fiber can get messy. You can get timing errors.
So you keep the sensitive control signals on the reliable copper.
And you put the massive data stream, we're talking 32.4 gigabits per second on the fiber. You get a perfect plug-and-play experience.
That 32.4 GBPs, that's HBR3 bandwidth, right?
That's the full DisplayPort 1.4 spec. It's enough for that 8K video and, up to 8 channels of high-fidelity PCM audio.
So your audio and video stay perfectly locked over 131 feet, which, as you said, is not a trivial problem to solve.
Not at all.
Now, for the installers listening, there's another piece of this puzzle. The physical build, we mentioned how thin it is, but the jacket material, this LSHF.
Low smoke and halogen-free. Yeah, that is non-negotiable in commercial buildings.
Why is that?
If you're running cable through a ceiling plenum in a hospital, an airport, anywhere public, you have to meet fire codes. Standard PDC jackets release toxic halogen gas when they burn. This stuff won't.
It's a major safety feature then.
A critical one. Plus, it has a tight bending radius, gold-plated connectors. It's designed to be pulled through a wall once and then forgotten about for a decade.
It's an infrastructure play.
Exactly. You're not buying a cable. You're installing a permanent data link. If you cheap out and that cable fails in 2 years...
the cost to rip the wall open and replace it is going to be way more than that initial $500.
Way more.
Which, on that note, the source we look at actually mentioned a discount code, 10% off.
For the thrifty professional, look, for a home theater nut, it's a steep price.
Yeah.
But for a mission-critical medical display or a broadcast control room, it's peace of mind.
It really just shows how the plumbing of our digital world has to evolve. We obsess over the graphics card and the screen, but the pipe connecting them is now an active, complex device in its own right.
And it makes you wonder, as we start pushing towards 16K and beyond, will the cable as we know it even exist? Or will it all just become a fiber tether, with the real processing happening somewhere else entirely?
That is definitely something to think about. Thanks for joining us on this deep dive into the bleeding edge of connectivity.
My pleasure.
We'll see you on the next one.